Up to now, we have spoken mainly about the initial airworthiness, and Johan has already said that some of the STCs and mission equipment can have certain challenges. For me, continued airworthiness is a very interesting subject, where for STC holders, I guess it's a nightmare. Because during the life cycle, if your design for some reason fails or you have in-service problems, it costs a lot of money probably to repair or to invest additional efforts, and you have to be prepared for the unexpected. I think that is the main thing, and that is also what the presentation is about. And I put together some slides that show you, that everything of continued airworthiness is based on reporting of the incidents. And occurrence reporting can be done via our aviation reporting portal, which I have given the link in the presentation. I will not say a lot more about that, but you are probably aware. If not, you should look at this page and find out how to report in-service difficulties. Lucky enough, there are not so many in-service difficulties reported from STCs, so I believe everybody is doing quite a good job with the design, so there are not so many problems. But I have also listed some problems that we have identified, and that comes later in my presentation. And from the occurrence itself, we have to determine with the design approval holder and STC holder which kind of mitigations and actions are necessary, for instance, ADs, which is also not very common on STCs because the number of aircraft affected by an STC is typically smaller, and therefore, EASA doesn't issue an AD for a single aircraft. It needs to be fixed anyway, but it's not a matter where an AD is issued. Instructions for continued airworthiness, they must be kept up to date and probably amended when something has been observed. Practical examples, I come later to that in detail. And then I wanted to add two different slides at the end of my presentation that is simply for reference. If there's a need to change ownership of an STC, for instance, you imagine Air Berlin went bankrupt, they had a DOA, they had STCs, and those aircraft need to continue to be operated, so you have to find out what to do. And this is just a list what you can do if change of ownership or STC holder has to be changed. And then flight conditions for STCs, if you do flight testing, most of you will be aware of that. I will just mention some items that I believe are important. On this slide, I have just put together the obligations of the TC holder and the STC holder with respect to continued airworthiness. It's 21A3A and 21A3B, and you see it's on both sides, the obligations are the same, and therefore you must know that you have a system to collect occurrence reports and to deal with them, and also to inform the EASA about them so that we can work together and fix the problems if they arise. There's guidance material and advisory material for this, and I just wanted to mention that material. I think you all know it and you can probably study it again. For instance, the AMC 21A3AB2 reporting to the agency, this refers to AC 20-8, and this is the reporting requirements from the past, but there have been recently also the reporting requirements by EU Regulation 376 and 1018, which changed a little bit the classifications of the occurrences that need to be reported, and this has still to be implemented in Part 21. So there will be changes in the future to implement this. Practical examples. The header of the slide says obligations for continued airworthiness. I would rather say this is best practices how to be prepared for the unexpected. you have to maintain relations to the TC holder. If you had some credit when you were designing your STC, then you also have to maintain relations to the PUA and probably the maintenance organizations that were installing your STC. If it's multiple installations, you have to know whether there were difficulties during the installation. Probably you had to have minor changes to adapt your STC for the specific aircraft, because not all airplanes are the same. And that's why I said you should request feedback from all the installations performed with the approved instructions. You have to keep, obviously, all the relevant documents up to date and have a list of STC installations and maintain customer relations so that you can, in the case that STC customers have problems, you can inform everybody who has the same problem or could have the same problem what the solution can be. Certainly, last line is the reporting to EASA. Not everything needs to be reported, but at least with a conservative classification, the items that could result in safety problems and potentially unsafe conditions. Miscellaneous things are obviously if an aircraft changes shouldership and goes to a non-EU product registration, then you have to support the new owner and probably ask for a validation of another country outside EU. And further on, if an STC is installed in an aircraft and an AD on that aircraft interferes with the STC or the other way around, there may be an AMOC developed just for that specific aircraft. Happens sometimes if electrical systems are changed and then probably the basic aircraft has a major upgrade of their electrical systems due to problems discovered in service that needs adaptation. So what is a list of potential problems that could happen in service? I listed just a few of them, and I come later to the individual problems that I wanted to list. Functional difficulties, unexpected wear, corrosion, probably flying over water, over the sea with a mission airplane, interference with other systems. This could be electrical or probably even mechanical interference of the new parts installed. Sometimes also replacement of COTS parts, commercial off-the-shelf parts that you have installed during your with your STC. They need to be replaced, and some customers want to buy them like a printer in MediaMarkt instead of using your qualified part or something like that. That could create in-service difficulties. And then you have also to look what happens to the basic type design. Sometimes the basic type design changes, and I will have an example for that. That may be interesting for STC, basically for the large antennas, for instance. So practical experience based on electrical systems. The first line is probably kind of guidance, that it is good practice if you have a non-essential system that you install via an STC to do a load shedding so that the loads are shed and the system doesn't function anymore in case of electrical problems of the basic aircraft. That's something that people do, some others don't, but I think it's a good practice. Another thing that is important with electrical installations, that some of the essential buses on some airplanes are pretty much loaded and do not cope with a lot of additional loads. So for instance, Airbus has issued guidance and documents to actually prohibit, which they are not allowed to, but they want to prohibit that people tap new equipment and users on their essential buses, which are very much close to the limit. And we had a long discussion about how this can be worded and whether we can design something, we can approve something where the TC holder is against it and has issued paperwork against such solutions. What can happen if something is not properly load shed or put on an essential bus? This is on the lower part of the screen. It was an accident of an MD-11, which was related to an STC installation of in-flight entertainment system. It burned under the cockpit, was non-contained, and the aircraft crashed. And this was because the overall integrity of the STC was not properly designed. What we have here is a very small thing, but it's on several airplanes. So the USB receptacles become very common in the cockpit area, and can be designed under minor change because they typically should not have a lot of impact on continued airworthiness, and they should not be a problem. But here it has been observed that they start smoking and burning, and the specific failure scenario is not so critical. It's not hazardous and can be managed by flight procedures, but it's certainly not good, and the approval holder is working on improvements. And EASA has agreed on this, that even the improved modification can be carried out as a minor change. However, finally it will probably result in an AD that affects several aircraft types where such USB devices are installed. Other example that I wanted to mention, and please excuse that I don't have nice pictures. It's just words, because I do not want to show too much detail of the problems. This was the first thing, cabin interior refurbishment, VIP interior. This is actually a production problem where the STC was fine and the cabinets installed in the cabin were properly justified by a burn test of samples, and finally within the production somebody decided that the paint would dry faster and be nicer to handle if the retardant for the flammability is removed, and this was not good. So this resulted in many discussions for several airplanes, and there have been retrofits with a very long compliance time of up to 12 years even, because the risk is not too high. It was not too many material that was wrong, and the probability of a single aircraft to have hazardous events related to that was low, so the compliance time was agreed to be 12 years. Cargo conversion, this was an STC actually where I was involved in when I was working early at EASA, and it's an American STC where even after 3 years already there were cracks in the structure of the cargo door frames, and there were FAA ADs which we adopted, but then at the very end the repetitive inspections and the replacement could be terminated by optional terminating action, better design that the FAA allowed to be optional, but the EASA decided that this needs to be implemented on all the affected aircraft for operation in Europe. Then some examples from helicopters. The first one is again something electrical, overheated and melted connectors in the air conditioning wiring. In this case, it was also action by the FAA, and they decided that this is not worse than AD, but they issued an SAIB, which is similar to our SIB, and recommends that the helicopters are changed and the systems are improved. Another item that has resulted in a Canadian AD is stretcher installation where on one side of the helicopter you install a stretcher instead of the seat. And it was installed in a way that some of the parts could interfere with the flight controls. And this was not seen in the initial installation, or it was probably also avoided during the compliance finding and the inspections. But obviously it could develop in service, and therefore there has been an AD to prevent that. Also, production tolerances can be an issue. I was involved in one of the programs where we did mission installation for police helicopters, and to have a cabinet behind the pilot seat was a clever solution to store some books and material and so on. So the STC was designed taking all the measures from one aircraft, from one helicopter, and then the 5 parts were produced. And on other helicopters, obviously, the seats could interfere with the size of the container. And since this is dynamically tested seats, you can imagine the repair was very expensive, and there's no, so there has to be a replacement. And since only 5 helicopters were affected, this has not resulted in an AD, but obviously it was very interesting for the STC holder company. One thing where monitoring of design developments is important, and this is an example from Airbus A320 fleet. Airbus did an extended service goal certification to come to a higher limit of validity of the overall aircraft to fly it longer. And some of the repairs and Airbus major changes and so on have been reviewed, or in principle it was a comprehensive review. They did additional fatigue testing and everything to show that their design is safe for the ESG, even when repairs are made and so on. However, they issued paperwork that required that STC installations that affect this airplane that is supposed to be operated for ESG need to be reviewed so that the instructions for continued airworthiness are adequate. And they issued in their service bulletin, this is hardly readable, excuse me for that, but I marked the text blue, and you will find the presentations later on, that the owner of the aircraft has to contact the STC holder and make sure that the ESG is properly covered by inspection requirements and so on. So that is something that was worded in a different way before. Airbus initially had a wording there that pointed to the STC holder that they are responsible for recertifying their STCs, and this was questioned by the airlines, for instance, using this aircraft, how this was meant, and we have agreed with Airbus to use the wording like that, so that the operator, when he decides to implement this service bulletin from Airbus, has to contact the STC company, and then they have to decide whether the provisions are already good for ESG or require a change to the ICAs and the ALSs, in which case this would be a major modification. Other things, monitoring design developments. We had problems with fan cowl doors opening in flight when they were not properly locked by maintenance before the flight, and we had modifications AD'd on the Airbus aircraft, but then we discovered that these fan cowl doors are also produced under STC, and therefore there was a need to develop the similar protection with a certain locking mechanism and a flag to make people aware that the cowling doors are not properly closed for those aircraft as well, because the initial AD mentioned certain part numbers, and obviously the monolithic fan cowl doors had different part numbers, therefore the AD was not applicable. Similar thing happened on avionic traffic collision TCAS. There was some interference that could cause nuisance warnings, and this was considered as an unsafe condition. We fixed it with a basic type design, but then we became aware that also STC installations exist, and therefore there was a need for another AD on those installations. If you would click the link, you will find the AD for information later on. So the last two slides that I have are, the first is for the transfer of STC certificate, where most people may know, if not, this is a help, that an STC can be transferred from one DOA to another DOA, from one company to another company. If the compliance data package and all the information is transferred, the STC holder has to apply for this STC transfer, and the receiver has to accept that he accepts the transfer, and he will perform in accordance with the obligations for the STC holder. So that is just a simple reminder how to do it, who has to be in charge, and I thought it would be worthwhile to mention here. The last slide that I have is for flight conditions for approval of permit to fly. Obviously, you have to do some flight testing for development and certification, sometimes customer demonstrations before the STC is approved. These flight conditions must be approved by either the EASA or a DOA with the respective privileges. And you know already that there's a EASA Form 37 for the application and a Form 18B for the flight condition approval itself, which we sign. This form has been revised last week to give an option for AOG, aircraft on ground, for the specific urgent cases. So you can make a cross, and in this case, EASA will react faster. However, I want to say that for STCs, we would typically not see this as an AOG, because you can plan early, and it's good practice to plan early and to discuss with the EASA team about the flight test requirements, the flight test program, who can fly it, what kind of test pilots, and so on. So, and also the level of involvement. And this would mean it's early enough and you can plan for it, and it's not an AOG case. One interesting point I wanted to make is that if many modifications are in the installation process of an aircraft, possibly two STCs at the same time, which are not approved, there can only be one flight condition for the aircraft. It doesn't make sense to have a flight condition on one system and another one on another system and put them together. Then there needs to be the complete configuration described, and for that you have to establish limitations and restrictions. This is something that went wrong on some installations sometimes and created problems and timing problems. So I hope that this was interesting for you and you're all prepared for the unexpected.
So Armin, we have just time for one question. We have received more than one, of course. One interesting question. Someone, and when I'm saying someone, it's on purpose. I'm not talking only about DOAs. Someone is applying for a minor change. Is this person or this organization bound to the obligation of reporting as per Part 21 A3A?
In principle, I would say so, but a minor change should not have airworthiness impact. But if so, then I wonder whether this owner of the minor change will become aware of it. Typically, I would expect that the operator would report such a case if he has an operational problem, and potentially he would report it also to the design approval holder. So I hope a minor change will only in very few cases be subject of an airworthiness problem.